Hi there, welcome to this third demo video for the Odds On Models same race multi-product that we've recently built. Just to recap, in the first one we looked at the product and the markets that we could offer. In the second video we looked at the scratchings and how our scratching innovation allows us to price up more markets. So in this one I'm just going to show some of the pricing nuance that can be added. This first view you can see here now, we haven't looked at it much, but this is just a mock-up of where the traded variables could be put in. So this column here, the price, is obviously the most important one. And to be honest, that does most of the heavy lifting here. What we're going to show is just some nuance that can, put tweaks in. At the end of the day, 100 to 1 shot's never going to be evens to come second, right? It might be a bit more or less likely. A favourite might be more likely to blow out and not get the lower positions. But ultimately, your win book is king here. So we're going to use this DK power column in a minute. The draw will be important for one of the variables, but I'm going to start back with a race setting. And this is now here. So this is the DK power. So if this DK power was set to 1, we'd actually have the Harville model. For any aficionados out there, that's a paper that's been used extensively for horse racing, and it came out in 1973, actually. So there's been some tweaks to that through the years. I made some tweaks myself for my PhD thesis 20 odd years ago, and I've added a few kind of bells and whistles since then. But if we look now, a good way to look at changing this DK power is to go here. So we're looking at the price for the top 3 here. So we know the top 2 are the favourites. They're 150 and 170. And let's look at these 2 here, Star Material and You Bet See This, which are the outsiders. So at the moment, they're 650 and 6 to finish in the top 3. If I change this and make this power smaller now, it's making the race for lower positions less competitive. So it really depends on the race, the nuances of that. So, for example, for a Group 1 race, perhaps, every horse is trying its hardest for every position. And so this DK power doesn't need to be as low. Whereas for a low-ranking race where horses are trying to get handicap marks and stuff, to try and get a win at some point, they might not put massive efforts in for the lower positions. So for this example, I'm going to change that to 0.7. So I'm just going to store these variables. I'm going to call this more DK. So I store them variables. So the second step in how we built this at the moment is to then do the calculation. So I'm doing the calculation now based on that variable change. So now in the back end, all the permutations have been worked out for that particular set. They're saved now. And then my third step is simply to go here and to change the prices in the UI. So there'll be a fraction of a second here, which is good because it will take me back and we'll be able to see the prices again just before they move. So if I create this here, so the 150 and the 170, so look, these have gone out, right? 167 and 183, and these have come in 550 and 5. So what this decay is doing is just making it just kind of shunt together. The thing I always use, although this model wouldn't exactly be right for the 100-meter race, if you remember when Usain Bolt, when he was probably 80, 90% to win every race. So when he didn't win a race, he probably wasn't going to come second. He was going to either maybe pull a hamstring or, full start or something go wrong. So that's this variable, and that's what that makes us able to do. So let's change it once more, just take it further. This is probably a bit further than you'd ever really go, I think, 0.5. So we'll put even more decay, store those variables. Go to the model, and again we'll change this to the even more decay one, save that as well, so we get our permutation saved. So now when I do the calculation with that third one and update that, 167, 183, so they've now gone 182, and these are into 450 and 433 here. So basically that's a nice trigger, a nice way to decide how competitive they think the race is. This can be done in various ways. We can look at historic data for different race types, different courses, different quality of race. It may well be different for the dogs and the trots than it is for the horses. It could also be a trading decision. So a trader could look at that before he puts his prices out, get exposure to those variables. Or it could be liability driven. So, the bets could be coming in. And so, for example, if you're getting loads of bets, on outsiders to place or something, it might be that decay's not quite right. So it's the same for the other variables here. We can drive them in different ways. So I'm just going to take this back now to the original scenario. So if I just go back, I'm just going to make this 0.9. I'm just going to call this original for myself. I could have just gone back to the original one actually, but I've done this now. So I'm going to store that again. This should be basically the same as the original one. So that's original. So I need this to be the original set of variables. So now when I go to product and do original, create the singles, and we're back to where we started. Look, 150 and 170 and 650 and 6. So those variables there, the decay power was for the whole race, and it's kind of a measure of the whole race. Well, we can also do it at a competitor level. So this is the race style of a horse or a dog now. And a nice way that we can do this is these two here. Look, they're the same price. So Go Vince Go and Born Slippy. They're both 8.5 to win. So obviously we want win price to be the same because that is our win price. But that's not to say they have to be the same for the lower positions. So this decay power works a bit like the other one, but it only kind of changes that horse, and it has to change the others by the definition of doing that, but it has less of an impact on the other ones. So we make one of these less than 1 and one of them greater than 1. So I'm having trouble with this value here. There we go, 0.8 and 1.2. So if we look at these two horses now and we go back just here, let me just run the thing. So we'll call this competitor decay, not recay. So I'll save that, store those variables, go through the process again. I've stored them. Now I need to run the calculation on them. So we run that here. And then finally we can go to the product. So before I run this, let's just have a look. So obviously they're both the same at the moment. The situation was symmetric, so they were both 3 decimal to get in the top 3. So now if I run this with the competitor decay, you'll see this comes through here. So look, the others have moved a little bit just to balance the books, but that's 153, 173 instead of 150 and 170. The 6 and the 650 have changed a little bit. But the main thing here is look at these two. So they're both the same price to be in to win the race, and you can see that back up here. They're both still 8.5, but now they're different for other things. So, this one is more likely to be second, and it's more likely to be third. And obviously, the resulting is for the top 3. We've moved this quite a lot here. So we've gone to 210 and 433, which is probably more extreme. I can't imagine a situation where 2 horses the same price to win would be that big a difference. So maybe we'll just ease back on that. We'll remember the 210 and 433. So we go back to the setup to those competitors. So now let's go 0.9 and 1.1. So they're still different, but they're closer to 1. So we should see the prices get closer back. So we'll call this less competitor decay here. Just get rid of that capital O. So if I store those race variables again, I go to the model, less competitor decay, run the calculation so we get the permutations, and then finally we run it. So less competitor decay, go here. So the 210 and the 433. So look, that probably seems more reasonable. We've got a 250 and a 360 here. So again, how these variables are controlled, there's different things we can do. So this decay power, it could be, it could be trader driven. We could be saying, well, look, we're getting a lot of bets on a certain horse to place or something. So we just want to, make it place price a little less attractive. Again, data on certain horses, I guess it's hard, if a horse had a few runs to, defiantly say it's less likely to place or more likely to place. But there's ways and means here, and we'll be more than happy to work with people on this stuff to facilitate, making it efficient to use. So I'm going to go back to normal again. So we've got one more thing to look at to do with the draw bias. So I'm just going to put those back to 1 again. We'll call this normal again. So I'll store those variables. Go here, normal again. We'll run that again, calculate that one. So now when we go back here and run normal again, if I put the numbers in correctly, they'll both go back to 3. So yeah, so there we have it. So we're back to kind of now our starting race, our most basic set of variables. So the third thing that we have at the moment is for draw bias. This is quite important for greyhound racing in particular. Tracks can be running very inside or outside. So if that's known, so if we know 5 races in a track's inside, there may be less need for the bias because it's kind of already established and it will be already impacted in the prices. So if in a dog race where all the dogs were as good as each other, they all should be, say, 7-1 with no margin. It might be that the inside one is 5-1 and the outside one is 9-1 or something. So perversely, in that situation, you might not need draw bias. But again, the way we're going to look at this anyway to see how the mechanic works is let's have a look at the situations here. So I'm going to look at this particular forecast, which is Amorim, which is draw number 1 here. And again, we can use these two that are the same. So Go Vince Go and Born Slippy. Now, if we look here, Go Vince Go, he's drawn 2. So he's very close to Amorim, whereas Born Slippy is right on the other side. So if we do expect some draw bias, we might expect the 1 and 2 price to be shorter than the 1 and the 8. So let's just go, let's go to our exotics tab. Here's a nice way to do this. So I'm going to look at the first 2 exact order. So let's have a look at number 2 to beat 7. So that price is 29. And it's also 29 to beat 8. Again, this is symmetric at the moment. There's no difference being applied to do with the horses or the draw bias. So if I go back here, I'm going to put the draw bias in of 0.05. So again, this is kind of just there's not really much intuition to this number straight away, but a trader using this will get to know it. Again, it can be liability driven, as I keep saying. So let's have a look here. Draw bias. I'll just put 0.05 because we might do a bigger one. So if I store those race variables, know this process by now, draw bias, we'll call that there. And then finally, we can basically do the pricing, draw bias. So create the singles there. So remember, they were both 29. So if we go here now and we re-input, so Amorim and Go Vince Go, and that was, remember, that was 1 and 2. If we look here, go back to here. So the one, when 1 wins, it effectively makes it more likely that the one draw number 1, so number 2 wins. Born Slippy is 23 to be second to him, whereas the other one now is out to 41. So there's other race types this is quite useful for. In horse racing, maybe straight races. Particularly in the UK, they have a lot of handicaps with 24 and 30 runners that are just spread out across the field. They tend to go into 2 or 3 bunches. So sometimes, the one bunch just gets the pace better, so they kind of all finish together. So that's kind of an area where you'd want this draw bias. Again, we can show the magnitude of it here. So I'll do one more. I'll go back to my my draw bias. So I'm going to make it twice as big now, 0.1. So I'll call that now draw bias 0.1. call that draw bias 0.1, run that one. Go to the product, final calculation here. So we do that. I think it resets this page when you update the prices. So we'll look once more. So now 2 to beat 7 is 19. So it's got shorter. Remember, it was 29 with none of this. And now it's up to 67. So basically, another nice way to just finesse the prices. The end of the day, if the favourite moves into 275, that's going to have a bigger impact than doing stuff like this to the overall book. But this just lets us, massage and manage what we have there. So, so that's a measure of the nuances we have in the algorithm at the moment. Just recall what I said in the second video. These nuances in the algorithm are specific to pricing, not to the scratching. So the scratching uses a simpler version of this, and it compares the before and after probabilities. That's where we're at. Happy to add more triggers here, levers. One lever I've thought about perhaps for the trots is correlation between numbers. They line up in rows, so sometimes a 50 to 1 shot behind an even money favourite probably isn't going to go round and get past him, but he could hold on for second. So that would be a specific, and perhaps their numbers 1 and 4. So you may just want combinations. So I guess we're looking at a matrix there for 10 runners to be like 90 combinations because you can't correlate with yourself. But I guess I'm rambling into, ideas for the future here. So I guess I'll leave it there. So thanks for watching these videos. And obviously feel free to hit us up with any clarifications. We're more than happy to demo this and, give some understanding of the technical requirements to get it integrated. As I said, it's very easy to use. It primarily uses your win book. So it can be quite a powerful tool to get a new product without too much trading effort. But yeah, let us know your thoughts. Thanks very much for watching the video.